Hello everyone, I am Ruth Minanisa and here are my teammates Afroza Yasmin Isha and Sulaina Rahman Adisha. Ever wondered what makes the difference between losing a tooth and saving it? Often it is a tiny hidden canal inside the root canal that keeps it alive. Our project uses micro-CT scans and automation to build a precise 3D map, helping dentists treat teeth more effectively. If a dentist needs to treat a damaged tooth, they must know exactly how those passages twist and branch. Micro-CT scanners can take incredibly sharp slice-by-slice pictures of the tooth, like looking at hundreds of very thin cross-section. But dentists don't need slices, they need the big picture. The challenge is turning those flat slices into an accurate, usable 3D model. Now, why 3D reconstruction matters? When a root canal treatment fails, one common reason is that a canal branch was never spotted and therefore never cleaned. Even a tiny missed channel can let bacteria survive that can lead to pain, infection, or even another surgery. So by reconstructing the canal in 3D beforehand, a dentist can see every twist, curve, and branch, which improves treatment planning and increases the chances of the tooth lasting for many years. Now, for problem statement, mapping canals from scans is a slow manual process. It is time-consuming, requires trained specialists, and results can vary from one person to another. So, our goal was to change this by creating an automated system that can detect canals, build a 3D model, and trace the main path, all with minimum human input and consistent accuracy. Then for methodology, we began with micro-CT scans of 4 teeth taken before treatment. Then we first removed image noise and cropped in on the tooth itself. Then we used automated segmentation method to pick out the canal from the surrounding material. After that, we refined the shapes so the boundaries were smooth and accurate and only made manual corrections when absolutely necessary. Then finally, we stacked all the processed slices together to create a full 3D model and then traced the center line for detailed analysis. Here is the result part. For 2D process, starting from the raw scan of micro-CT slice images, then isolating the canal region and removing the small object part, and finally getting a clean, smooth outline ready for 3D assembly. From the 3D model, we extracted the canal's main path. This is important for measuring curvature and for deciding the right tools during treatment. Finally, this is the final product, a clear 3D reconstruction showing the root canal center point. Next, we want to test our system on more complex post-treatment scans, use deep learning to improve canal detection, and work with larger datasets from different sources to make sure it performs well across many real-world cases. So to sum up, our method shows that it is possible to automate root canal mapping from micro-CT data, making the process faster, more consistent, and potentially more reliable for dentists. Thank you for listening, and I will be glad to answer any questions. Thank you so much.